These are the notes for Algebra 2, Section 6.4. This is Part 2 of dealing with inverse functions. And we're going to be looking specifically at inverses of power functions. That is, inverses of functions where we have x to the second, x to the third, x to the sixth, so on. Now let's dive right into it. Go to example 1. Now, of course, keep in mind, when we're talking about finding the inverse, we have a couple of things that we need to know. First, the inverse of the function is what we get when we swap x and y. Second, what we're doing is basically just solving for y. So, first thing we would want to do here is change this f of x to y, just so we know what we're looking at. So, instead of f of x equals 4x squared, we have y equals 4x squared. So, we want to swap, just like we did in the last video. We swap x and y, and we get x equals 4y squared. And we want to solve this equation. To solve this equation, we would start by dividing by 4. So we divide by 4, we get 1/4 x equals y squared. Now we're solving for y, and y is squared. To undo squaring, we take the square root. So the square root and the square will cancel out. On the other side, we take the square root. The square root of 1/4 is 1/2. Square root of 1 is 1. Square root of 4 is 2, so that's 1/2. Since it's in an equation, it's positive or negative 1/2, because it could be either one. The square root of x is just the square root of x. So we have y equals plus or minus 1/2 square root of x. Now you might have noticed in our problem, x is less than or equal to 0. What that is what's called a restricted domain. That's telling me that when I'm setting up this function, the only x values that I'm going to look at are the negative ones, right? X is less than 0. So I can do that. I can specify, for this function, only look at -1, -2, -3, so on and so forth. Now, when we do that, it does have an effect. For instance, the domain of f in this case, right, the domain of the function f, is restricted to the negative values of x. What that means is the range of the inverse must also be restricted to negative values. And the reasoning behind that's a fairly simple one. As you know, for an inverse, the x's and the y's switch places. So that means that the domain and the range switch places, because the domain is x and the range is y. So the domain of the function f is the same thing as the range of the inverse of f, because domain and range switch places. So if one happens to be restricted, then the other also has to be restricted. Therefore, the inverse is f to the negative first of x. The inverse of x equals negative 1/2 square root of x. So that plus or minus that we had in our problem here, that plus or minus, became just minus. The reason being that the range has to be negative. So the plus or minus became minus. If the domain were restricted to the positive numbers, x is bigger than 0, then you would choose the inverse of f of x is positive 1/2 square root of x. So we chose either positive or negative based on this restriction of the domain. Okay. Now, one thing that tends to happen with power functions is the graphs can curve. And we need to know if the inverse of a power function is also a function, because it might not necessarily be that way. To do that, we use what's called the horizontal line test. Now, we've seen the vertical line test. The vertical line test says that a relation is a function if you can move a vertical line across it and it never touches, and it never touches in more than one spot. Right? That means that the relation is a function. Now, the horizontal line test says that the inverse of a function, right, when we swap the x and y and solve for y, the inverse of a function is also a function if no horizontal line intersects the graph in more than one place. So it says the inverse of the function f is also a function if and only if no horizontal line intersects the graph of f more than once. So as an example here, this would be a variation on x to the third, y equals x to the third. You can see I have this horizontal line here going left and right. If I move this horizontal line along, it would never cross the function more than once. So the inverse of y equals x to the third is also a function. On the other hand, we have a variation on y equals x squared. You can see that my horizontal line immediately crosses in two places. That means that the inverse of y equals x squared is not a function. Right? So that's a way to tell. Let's look at example 2 and notice, with that in mind, that we want to determine whether the inverse is a function. Right? That's the first thing we have to do, determine whether the inverse is a function. The easiest way to do that is to graph it and look at the graph with the horizontal line test. So I have plugged this graph into my calculator, and this is what it looks like. Now, if I did the horizontal line test, let's make a copy of this and put it in our notes here. Zoom in, way in on this. We can make it nice and big. Now here I have the graph of this function. You can see that if I were to create a nice horizontal line, this horizontal line would not touch this graph in more than one place. Okay, it wouldn't do it. Right, so here's my horizontal line moving up and down, never touching the graph in more than one place. That means that the inverse is a function, right? So I'm just going to write inverse is a function. That is the first thing I need to do. Right? The inverse is a function. Alright, so with that in mind, we want to find what the inverse actually is. And we start that the same way we start all of them. Here's our original function, 1/4 x to the third plus 3. We're going to replace f of x with y. So we get y equals 1/4 x to the third plus 3. We switch x and y. Notice these are all exactly the same steps. So x equals 1/4 y to the third plus 3. And we solve the equation. Subtract 3, subtract 3. We get x minus 3 equals 1/4 y to the third. Now we want to get rid of this 1/4. And the best way to get rid of this 1/4 is to multiply by 4. So that's what we're going to do. We're going to multiply both sides of our equation by 4. You could divide both sides by 1/4, but keep in mind that dividing by a fraction is the same thing as multiplying by the reciprocal, and the reciprocal of 1/4 is 4. So when I multiply by 1/4 on one side, I get y to the third. On the other side, I get 4x minus 12. So far, so good. Now, the last thing I have to do is take the cube root of both sides. Now, this is y to the third. So the way to undo y to the third is to take the cube root. Now, we haven't seen these before, But it should stand to reason that if the way to undo a squaring is to take the square root, then the way to undo cubing is to take the cube root. And that's what we do. Right? We did see cube roots when we were talking about rational exponents. Right? This is basically, what do I multiply 3 times to get y to the third? And what do I multiply 3 times to get 4x minus 12? Now this is saying that the cube root of y to the third, the cube root, and the cube cancel each other out, and we get y. On the other side, we have the cube root of 4x minus 12. Now, there is not much we can do with that. In fact, that is as simple as it gets. So the inverse of our original function, 1/4 x to the third plus 3, is the cube root of 4x minus 12.